The ancient world once measured its beauty not in miles or riches, but in the elegance of a line, the curve of a bow, the arc of a planet, the circle of the sun upon the sea. Long before telescopes or calculus, there were men who sought to understand the invisible order behind all things, to find in geometry the hidden rhythm of the cosmos. Among them rose one name that time almost forgot, Apollonius of Perga, the man who gave form to infinity. The story begins in the 3rd century before Christ, when the world map of knowledge stretched across the lands conquered by Alexander. From the sands of Egypt to the marble cities of Greece, from the valleys of Anatolia to the shores of the Aegean, a new kind of empire had been born, not of armies, but of ideas. It was an age when philosophers wrote the laws of nature with ink instead of iron, and astronomers charted the heavens as carefully as merchants traced coastlines. In the bustling city of Alexandria, the world's greatest library stood like a temple to human curiosity. Scholars gathered there from every corner of the Mediterranean. Mathematicians, astronomers, physicians, poets. Scrolls filled with the knowledge of Egypt, Babylon, and Greece lay stacked in endless halls. There, the geometry of Euclid had already drawn perfect lines across parchment. Archimedes had bent mathematics into the shape of machines and the physics of water. But a new challenge lingered among the scholars: the geometry of the curve, the mathematics of motion and celestial shape. Far to the east, in the city of Perga in southern Anatolia, a child was born under the reign of the Ptolemies, a boy whose name would one day be whispered with reverence in the same breath as Euclid and Archimedes. Apollonius. Little is known of his youth, but the lands around him were alive with Hellenistic wonder. Marble temples gleaming in the Anatolian sun, bustling markets where Greek and Persian traders bartered goods and knowledge alike, and observatories where the paths of stars were drawn upon wax and clay. By the time Apollonius came of age, the intellectual current of the Greek world flowed irresistibly toward Alexandria. The great library was more than a collection of scrolls. It was a living mind. Every dawn, the courtyards filled with scholars debating the harmony of the spheres, the weight of air, the perfection of the circle. Ships arriving at the harbor were searched not for contraband, but for books. Every scroll copied and preserved in the name of learning. It was here, in this sacred heart of knowledge, that Apollonius would refine the language of geometry into a tool capable of describing the heavens themselves. His teachers, disciples of Euclid, spoke of straight lines and perfect circles. Yet Apollonius saw that nature was never truly straight. The paths of planets, the arches of bridges, the petals of flowers, all followed the logic of curves. Where others saw imperfection, he saw law. Where others found mystery, he found form. He studied under the successors of Eudemus and Conon, men who had once known Archimedes and carried forward the legacy of Hellenistic mathematics. The instruments of learning were simple: compass, stylus, and sand. Yet through them, entire worlds were drawn. On flat boards dusted with fine sand, Apollonius traced lines and arcs with the precision of a sculptor. The elders watched as he bent the circle into ellipses, parabolas, and hyperbolas, shapes unseen by most of his peers, yet existing in every curve of the heavens. In the evening, Alexandria's great lighthouse, the Pharos, cast its flame across the sea. To sailors, it was a beacon. To scholars like Apollonius, it was geometry embodied, a tower of proportion and symmetry built on the same principles he studied. Every column, every stair, every spiral reflected the perfection of mathematical harmony. It was said that when the flame of the Pharos burned, it could be seen 30 miles away, a human-made star guiding men through darkness. Apollonius often walked along the harbor's edge, scrolls tucked under his arm, watching the reflection of the lighthouse shimmer on the water. The rippling pattern, the wave of light bending with the sea, fascinated him. He saw in it a law of curvature, a meeting of geometry and motion. These were not the idle musings of a philosopher, but the seeds of what would become one of the greatest mathematical treatises in antiquity, the Conics. The Conics were more than geometry. They were the grammar of the universe. In them, Apollonius defined the ellipse, the parabola, and the hyperbola with precision so profound that astronomers 1,000 years later would use his words to describe the orbits of planets. To understand a curve, he realized, was to understand movement itself. The way a thrown spear arcs through air, the way the sun's path changes through the year, the way a planet traces its dance around the stars. But his journey was not one of discovery alone. It was a continuation of the Hellenistic quest for unity between mathematics, nature, and philosophy. The Greeks believed that geometry was not merely a tool, but a mirror of the divine, that to comprehend a form was to touch the mind of the cosmos. Apollonius became, in essence, both a mathematician and a priest of form. His diagrams were offerings to understanding itself. From the halls of Alexandria, his reputation spread across the Mediterranean. Scholars in Pergamon, Syracuse, and Rhodes wrote to him, seeking copies of his treatises. His correspondence with Eudemus of Pergamon, preserved in fragments, shows a man deeply aware of his place in the lineage of knowledge. He wrote not with arrogance, but with devotion, refining each proof as if chiseling stone. His work reached as far as Hipparchus, the astronomer who would later use Apollonius's geometric principles to explain the motions of the moon and planets. It was Apollonius who gave later scientists the mathematical tools to measure the heavens. His conic sections became the scaffolding upon which celestial mechanics was built. As the years passed, the flame of the Pharos continued to burn, and Apollonius's curves continued to ripple outward through time. His life was not one of conquest or power, but of silent, precise creation. Lines drawn in sand that outlasted empires. The night sky over Alexandria was the same one we see today. Infinite, curved, eternal. And beneath it, a man named Apollonius taught the world to see shape in the shapeless, order in the infinite. He gave humanity a new language, the geometry of the cosmos. Across the golden libraries of Alexandria, Apollonius of Perga carved his place among the immortals of geometry. Born in the 3rd century BCE in the coastal land of Pamphylia, he entered a world where numbers were poetry and shapes were divine. Alexandria, the radiant city founded by Alexander the Great, had become the beacon of human knowledge, its marble halls echoing with the footsteps of scholars, its papyrus scrolls breathing the memory of Greece, Egypt, and Babylon. Within this temple of wisdom, Apollonius studied under the heirs of Euclid and Archimedes. But he was not content to merely inherit geometry. He sought to transform it. His mind turned to the mysteries of the conic sections, the ellipse, the parabola, and the hyperbola. shapes born from the simple act of slicing a cone. Where others saw curves, Apollonius saw universes of motion, light, and proportion. His monumental work, Conics, written in 8 volumes, was unlike anything the ancient world had ever seen. In it, he defined these curves with mathematical precision, giving them names still used today. The ellipse, the closed perfection of celestial harmony. The parabola, the path of a falling arrow, or the flight of a comet. The hyperbola, the open curve of infinite pursuit. For Apollonius, geometry was not static. It was the language of creation, a code that revealed how the heavens moved, how planets curved through invisible paths, how light itself could bend and dance. Centuries later, Johannes Kepler would use those same conic sections to describe the orbits of the planets around the Sun. In every ellipse drawn in a textbook or calculated by a spacecraft, the shadow of Apollonius still lingers. His insights rippled outward, from Alexandria to Pergamon, from scholars to astronomers, from ancient scrolls to Renaissance diagrams. The geometry of Apollonius became the geometry of the cosmos, but behind the brilliance was a quiet humility. Apollonius never built temples or ruled kingdoms. His empire was written in ink and logic. In a civilization where heroes conquered by the sword, he conquered by the mind. And when the Library of Alexandria fell to flames centuries later, much of his work was lost. Yet the essence survived, carried by Arabic scholars, preserved in translation, revived in Europe, and reborn in modern science. He had bridged the gulf between the abstract and the eternal. His geometry became the skeleton of the universe, a silent architecture behind the stars. When the last embers of Alexandria's great library faded into the night, so too did much of the memory of Apollonius. His scrolls, those fragile vessels of genius, were scattered by time, war, and ignorance. Some were consumed by fire, others hidden in forgotten vaults, and a few, perhaps, carried by nameless scribes across the deserts and seas. Yet ideas, once born, rarely die. They drift, invisible through generations, waiting for minds ready to rediscover them. And so, while the stones of empires crumbled, the geometry of Apollonius continued to move in silence, like the orbit of a distant planet, unseen but unbroken. In the centuries that followed, across the golden sands of the Islamic world, scholars in Baghdad, Damascus, and Cordoba became the new guardians of Greek wisdom. There, under the Abbasid caliphs, in the shimmering halls of the House of Wisdom, translators labored by lamplight over the surviving fragments of conics. Apollonius was reborn in Arabic. Abul Wafa, Al-Kuhi, and Thabit ibn Qurra whispered his theorems into the language of algebra and astronomy. They refined his logic, expanded his equations, and linked his geometry to the motion of the stars. Through their devotion, the geometric flame was kept alive, burning quietly in the libraries of the East, while Europe slept through its dark age. Then, as centuries turned, those same manuscripts journeyed westward, carried through Andalusia into the heart of Renaissance Europe. In Venice, in Paris, in the universities of Padua and Oxford, scholars opened the resurrected texts of Apollonius and found a lost cosmos inside. His conic sections, once mere abstractions, now described the paths of celestial bodies, the optics of telescopes, the symmetry of art and architecture. Kepler's planetary orbits, Galileo's parabolic experiments, Newton's gravitational curves, all traced their lineage back to a man who had once drawn circles on parchment beneath the Egyptian sun. Apollonius had become timeless, not as a relic of Greece, but as a foundation of the modern world. Every spacecraft that plots a trajectory across the void, every satellite that arcs gracefully around Earth, every equation that maps light and motion, all follow the geometry of his thought. And yet, perhaps his greatest gift was not in the curves he named, but in the vision he carried. That truth lies not only in conquest or in empire, but in the pursuit of understanding. In the patient drawing of a line, the tracing of a curve, the quiet wonder at the laws that bind the universe. Today, when we gaze upon the elliptical orbit of a planet or the parabolic arc of a bridge, we are seeing echoes of Apollonius, the man who saw order in the infinite. His lost scrolls may have vanished to dust, but their essence endures, woven into every formula, every map of the cosmos, every exploration of light and space. For in the geometry of the world, his spirit still lives, the eternal geometer of the stars, whose compass once measured not just shapes, but the reach of human thought itself. In the centuries that followed Apollonius of Perga's quiet death, his name drifted into the folds of forgotten parchment. Yet the ideas he carved in ink did not fade. They lingered in observatories lit by oil lamps, in monasteries where scholars whispered of the ancients, and later in the laboratories of a Europe rediscovering the light of Greece. Long after his lifetime, the words conics would reappear like a constellation seen once more after long, clouded nights. From Alexandria to Baghdad, the journey of his work mirrors the movement of stars across the ancient sky. When the great libraries of Greece fell silent, it was in the Abbasid world, in cities like Harran and Baghdad, that Apollonius was reborn. Arabic scholars translated his scrolls into their language, calling him Balus al-Bark, the Wise One of Perga. The House of Wisdom became the new Alexandria, and Apollonius's geometry lived again under the brilliance of the Islamic Golden Age. It was there that mathematicians like Ibn al-Haytham and al-Tusi studied his principles, expanding them into optics, astronomy, and mechanics. Circles, ellipses, parabolas, and hyperbolas, the figures Apollonius had once drawn in the dust of Perga, became tools for predicting the motion of stars and the paths of light itself. Centuries later, in the heart of Renaissance Europe, Apollonius's legacy would ignite once more. Scholars like Commendino, Kepler, and Descartes rediscovered his conic sections. His diagrams, copied from Arabic and Greek manuscripts, guided the hands of men who sought to measure not only the heavens, but the invisible laws beneath them. When Johannes Kepler described the orbits of planets as ellipses, breaking free from centuries of circular perfection, it was Apollonius who had already drawn that truth in the geometry of the cosmos. His mathematics became the unseen architecture of astronomy, uniting heaven and earth through form, distance, and curve. But beyond the technical and the abstract, there was something deeply human in Apollonius's quest. He did not seek wealth or power, nor did he command armies or build monuments. His ambition was quieter, to understand the order hidden within the chaos of the world. To him, geometry was not mere calculation. It was philosophy expressed in shape and light. He believed that behind every curve lay a secret of creation, and that through reason one could glimpse the harmony that the gods themselves used to design the universe. In that pursuit, Apollonius stood among those rare spirits who turned thought into immortality. Imagine him now, centuries removed from us, standing once again beneath the Greco-Roman sky. The Sea of Pamphylia stretches far below the cliffs of Perga, the same horizon where traders, soldiers, and philosophers once crossed. Around him, the evening air is heavy with salt and the scent of olive groves. He gazes toward the twilight, that hour when earth and heaven blur, and he sees not stars or clouds, but geometry itself written across the fading light. Circles in the sun, parabolas in the flight of a bird, hyperbolas in the curve of a shadow across stone. To Apollonius, nature was never silent. It spoke in lines and arcs, a divine language only the patient could learn to read. When his conics spread across cultures and continents, it did more than describe curves. It traced a lineage of thought, a chain connecting Greek philosophy to Islamic science, and from there to the modern mind. Without Apollonius, there could be no Kepler's ellipses, no Newton's laws of motion, no calculus to measure the infinite. Even the great telescopes that now pierce the edges of the cosmos, mapping galaxies millions of light years away, follow paths first drawn by a man with a compass and parchment 2,000 years ago. The story of Apollonius is not one of conquest, but of continuity, the unbroken line of knowledge. Each era rediscovered him in its own way, finding new meaning in the curves he defined. In the silent rooms of medieval translators, in the academies of the Renaissance, in the observatories of the Enlightenment, Apollonius was there, unseen but essential. The geometry of his thought became the framework upon which all future science would rest. And yet, there is a quiet poetry in the way history remembers him. A figure without a monument, a thinker whose temple was the mind. His name, written on a handful of fragile scrolls, survived wars, fires, and the erosion of empires. Today, when a mathematician studies conic sections or an astronomer traces an orbital path, they continue a dialogue that began on the shores of ancient Anatolia. Each theorem, each measurement, is a whisper echoing back through time, from our telescopes to his quill. In the end, Apollonius's genius was not only mathematical, but philosophical. He understood that geometry is not just a human invention. It is the fingerprint of the universe itself. The same curves that shape a planet's orbit also define the arc of a wave, the petals of a flower, and the very motion of light. In studying them, he sought to reveal the symmetry between the heavens and the earth, to bridge the human and the divine through reason. As night falls over the ancient Mediterranean, imagine one last scene. The marble ruins of Perga, bathed in moonlight. The stones are cracked and silent, yet beneath them lie the invisible foundations of all that came after. The stars above trace their slow, elliptical paths, the very orbits that Apollonius once envisioned. In the silence, geometry breathes. The curve of the horizon, the spiral of the Milky Way, the fall of light upon stone. All are reminders of that eternal idea he pursued, that within every shape lies the order of the cosmos, waiting to be understood. And so, across millennia, Apollonius speaks still. Through every equation, every orbit, every mind that dares to measure the world and call it beautiful. His voice, though ancient, is woven into the mathematics of the universe. We may forget his name, but not his gift. For wherever thought bends toward truth, and knowledge curves toward the infinite, there walks Apollonius, the geometer who measured eternity in the language of the stars.